Okay, here we are with lesson 8, chapter 1 on roots. First thing I would like you to do is I need you to make a table of all the perfect squares 1 through 30 and put it in your notes. What I mean by that is I want you to write 1 squared equals 1, next line 2 squared equals 4, 3 squared equals 9, etc., etc. Do it for 1 through 30. So you're probably going to use one entire row, and then you might start the next row here, and then we will have space right there for something that we're going to do in a later lesson. So please make sure you do that. It will make seeing some of these concepts over the next several lessons much easier to see it by putting this in a table. Please make sure you do this step. Example 1. We are looking for the square root of 64. Now clearly you could just plug this into your calculator, but part of getting to know all your perfect squares is you should recognize right away that the idea of square root is basically they're asking you what number times itself will give you that number. And obviously 8 times 8 gives you 64. So the square root of 64 is 8. Now when they ask it in this format here, they are asking for the principal square root. And in this case, we only give a positive answer, because that's what they're asking when they do it like this. Okay? In example number 2, they now have a plus or minus out in front of, outside of the radical. This symbol here is called the radical. It is outside the radical, so they're asking for both answers, because if you think about it, I wish they had just used 121 here, and then it would be easier to see that the square root of 121 is 11. But go ahead and check this in your calculator if you need to. Verify that 1.1 times 1.1 is 1.21. If it's negative 1.1 times negative 1.1, it will still be positive. Negative times a negative is still a positive answer, and it'll be 1 and 21/100ths. So in this case, we put both answers. You can write it this way, plus or minus 1 and 1/10, or you can write it this way, 1 and 1/10, comma, and then negative 1 and 1/10. Either way is correct. Example number 3. This is why it's important for you to get to know your perfect squares, because kids that know their perfect squares see this as one perfect square over another perfect square. So when we take and now they're asking for the negative, notice it's outside the radical, so we're automatically going to have a negative number, and now we can just look at this and say, okay, I want to figure out what is the square root of 25. Break this into 2 pieces. What is the square root of 25? 5. And that's over the square root of 36, and that's 6. And remember, because the negative sign was outside the radical, we have to have a negative answer. So it's negative 5/6. And put this in a calculator if you'd like. Put negative, then put second square root, 25 divided by 36, and you should get, although you're going to get a decimal now that I think about it, but you will get a negative answer. Okay, and it will be the decimal equivalent of 5/6. Example number 4. The square root of negative 16. In this case, the negative is inside. So what they're asking is, what number times itself will give you negative 16? Well, either a positive times a positive would give you a positive answer, or a negative times a negative will give you a positive answer. A negative 4 times a positive 4 will give you negative 16, but that's not the same number, so this flat out is not possible. And you want to put this phrase in your notes if you need to, because this is how you're going to answer this question. You're going to say no real solution. There's no real solution to this problem. You cannot take the square root of a negative number, the square root. Okay? Put that in your notes. Please do letters A through D. Example number 5. In this case, they say to solve and check your answer. That's an important step here. Make sure you do that. We've got t squared equals 169. Well, remember that we can do anything to one side of the equation as long as we do it to the other side of the equation. So since we don't want to know what the variable squared is, we just want to know what the variable is. Obviously, if I take the square root of t times t, the square root of that, t squared, is t. So now I have t, and that's what I'm looking for. But if I take the square root of this side, like I do here in red, then I must also take the square root of the other side of the equation. And the square root of 169, you should recognize right away, that's a perfect square of 13. And now in this case, because we're solving problems with a variable squared, we don't know if we want a positive or a negative answer, so we're going to get both. Either 13 and negative 3, or plus or minus 13, either way. Now we check that. 13 times 13 Yep, 169. Negative 13 times negative 13 would be positive 169. Both check. We've got a good answer. Please press pause and do letters E through G. Okay, the next thing I'd like you to put in your notes is to put a definition of cube root and also add 1 through 10 perfect cubes to your table. So in other words, you're going to put in your table, hopefully you had a piece of paper like this where you had 1 through, let's say, 25, and then 25 through 30 here, and you've got some space here. So now you're going to put 1 cubed, a little bit bigger down here. 1 cubed equals 1. 2 cubed equals 2 times 2 times 2, so that would be 8. If you need a calculator to fill in this table, go ahead, get it in a table on one page in your notes. Mark that page in your notes. You're going to be referring to it. Okay, so get this done, put it in your notes. This is the format for cube root of a number. There will be a little 3 there. If it's just the radical sign, they imply the square root. And learn to use your calculator, because many of you have different calculators. Learn to use your calculator to calculate cube roots if necessary. There's a different procedure based on what type of calculator you have. Come and see me. I guarantee I can help you, but I can't give you instructions on all the different types of calculators. So now we're on to example 6, the cube root of 125. So they're asking you what number times itself 3 times will give you the number 125. Well, we can do this one of several different ways. You can look at your table. You should have it in there. The cube root of 125 is 5. You can use your calculator, and I suggest even if you had this answer, learn to use your calculator for some that you're not going to be able to do that for. Find the cube root of 125 is 5. Or you can just plain flat out use your brain. Many of you can see that we have a 5 here, so let's think about 5. 5 times 5 is 25. And then in your head, many of you can think about 5 sets of 25, that's like having 5 quarters, that's $1.25, that's 125. And this is the correct answer. Okay, so several different ways to do that problem, and I'm okay with any of them. Example number 7, we need the cube root of negative 27. Now you probably have noticed that there's a negative inside the radical, and you're thinking, wait a minute, there must not be any real solution. But in this case, we're looking for cube root, and there is a real solution, because we can take negative 3 times negative 3, and that equals positive 9, and then multiply one more time times negative 3, and it is indeed negative 27. So negative 3 cubed is 27, so therefore if we take the cube root of negative 27, we will get negative 3. Negative answers are okay in the case of cube roots, because negative times a negative times a negative will be negative. Please press pause and do letters H through J. Lastly, example number 8. We are doing the word problem here. Dylan's planter has 8 cubic feet of potting soil, and they want to know what is the side length of that pot, because it's cubic in shape. So we have S cubed, because length times height times width, which in the case of a cube is S times S times S, will give you the volume. We know the volume is 8 cubic feet. So we have S cubed equals 8. We take the cube root of this side. The cube root of S cubed is S, and the cube root of 8 is 2. 2 times 2 times 2 will give you 8. So we did our check. 2 times 2 times 2 is 8. We have a good answer. And you have to ask yourself, because we started out with S cubed, we're going to use positive or negative numbers if they apply. But does a negative 2 feet for the side length of a planter make any sense? It does not. So this is our only answer. Please press pause and do letter K. Okay, here are your lesson 8, chapter 1 letter solutions. First of all, we are asked to find the square root of some numbers. First problem is A, the square root of 9/16. Again, because we know our perfect squares really well, we realize we can separate this into the square root of 9 over the square root of 16. Square root of 9 is easy, 3 over the square root of 16, 4. So the square root of 9/16 is 3/4. Again, this would work in a calculator, but they're going to give you a 0.75 for your answer if you put this in a calculator. Letter B. In this case, they want plus or minus. So the first thing I would do when I write this problem out is write plus or minus, and I'll get my answer. Now, if you want to put this in a calculator, you can, but the square root of 81 is 9, so you should probably see the square root of 81 1/100 as 9/10. But go ahead, put it in a calculator, verify, and don't forget that you need both plus or minus in this case because they asked for it. Letter C, the negative square root of 49. Well, the square root of 49 is 7, so the negative square root of 49 must be negative 7. That would be the quickest way to do that problem. Letter D, the square root of negative 100 has no real solution. There is no number you can multiply by itself to get a negative answer. Can't be done. Letter E, 289 equals a squared, and in this case you're asked to solve these. So we've got 289 equals a squared. First thing we want to do is take the square root of the variable, and then we need to take the square root of the other side. Square root of a squared is a times a equals a squared. And the square root of 289 is 17. And remember, anytime you start with a variable squared, first thing you ought to think about is I need to have both the positive and negative answers here. So plus or minus 17, and we could check that. Use a calculator if you have to. 17 times 17 is 289. Negative 17 times negative 17 is also positive 289. F, we have m squared equals 0.09 or 9/100ths. Therefore, we're going to take the square root of both sides. Square root of m squared is m. The square root of 9/100ths is 3/10. This will confuse some kids because you're seeing 2 digits here and we go down to 1 digit here. But do it in a calculator if you have to. Prove it to yourself. 3/10 times 3/10. In other words, a number smaller than 1 times another number smaller than 1 is going to give you an even smaller solution. That's the way to look at that. Just like a number larger than 1 times a number larger than 1 will give you a solution that's larger than either of those two numbers. 2 times 3 is even greater than 2 or 3 at 6. Well, it's going to be the opposite when you get on the other side of the number line, is the way to think about that. Letter G, y squared equals 4/25. Again, right away we see that we have perfect squares here, and right away we're going to take the square root of both sides. Square root of y squared is y. Because we took the square root of a variable, we're going to go plus or minus. Square root of 4 is 2. Square root of 25 is 5. Plus or minus 2/5. Now we're being asked to find the cubic root of the following numbers. So the cubed root of 729, I would suspect that most of you are just going to put these in a calculator. Hopefully you already had 1 through 10 in your table, so you could use that like I told you. And this one's easy. 9 times 9 times 9 will yield 729, so the answer is 9. Cubic root of negative 64. First of all, we're going to have a negative answer. A negative times a negative times a negative 3 times will give you a negative number. And 4 times 4 times 4 is 64. So negative 4 would be the cube root of negative 64. And letter J, you should see this right away as having 3 zeros, so 10 times 10 times 10 gives you 1,000. So the cube root of 1,000 is 10. Letter K, we have a cube-shaped or a cubic aquarium that holds 25 gallons. And notice I put so as in so what here, because they also tell you that it's 3.375 cubic feet of water in there. So this, we really don't need this. This would be of no use to us unless we went online and found the conversion factor for it. But they gave us this, so we're going to use it. And they ask us, what is the side length? Well, the first thing we're going to do is, since they asked us the side length, we're going to say, let's let S represent the side length. So we have side length times side length times side length 3 times because it's cubic in order to get the volume. So S cubed, S times S times S, equals 3.375. or 3 and 375 1,000ths. Take the cube root of S cubed, we get S. Take the cube root of 3 and 375 1,000ths, and we get 1.5. Some of you, again, will look at this and think that doesn't make sense. Verify it in your calculator. 1.5 times 1.5 times 1.5 does indeed yield 3.375. Please do the guided practice.